Good morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today in this session, I want to discuss about bushed pin type of flexible coupling design. So how to design of a bushed pin type flexible coupling. Already we have studied about rigid coupling and flexible coupling in previous sessions. So in this session, I will explain the design procedure of a bushed pin type flexible coupling. See in this slide shown the bushed pin type flexible coupling. Here shown here shaft one end and another end of the shaft. So having a projection. So these are flanges 1 and flange 2. With the help of bolts and nuts, the two shafts are joined together. What are the dimensions of the flanges and what are the dimensions of the hub and what is the diameter of the shaft you should calculate in design. The same procedure how to apply here as the flange coupling design. The only difference is here extra one bush is added, the brass bush that is 2 mm thick to control the vibrations for flexibility. So the flexible couplings are allow some misalignments. So that is the difference between this rigid coupling and the flange coupling as we studied in theory part. Here the D is the diameter of the shaft and capital D1 is the pitch circle diameter, L length of the planes, clear hub diameter, capital D, 2 times of the shaft diameter. See here brass bush dimensions, bolt dimensions you have to calculate, and finally you have to check for the bending strength of a pin. See the design of bushed pin flexible coupling shown in this slide. The power is transmitted by the shear resistance of the pin. As the flange on the input shaft rotates, it exerts a force P on each rubber bush. So as shown in the diagram here, the cross section of the rubber bush. Resisting force, that is a bearing load on the each pin or a rubber bush on a rubber bush as shown in the figure. See, you can see in this diagram the bearing load acting on each pin. So how much load acting? You should calculate the bearing area multiply with length force. That is bearing pressure. Bearing pressure multiply with bearing area shown in this diagram. So as the flange on the input shaft rotates, whenever shaft rotates, it exerts a force. It exerts a force on each rubber bush. That's why you should calculate how much load acting on each pin. The total bearing load on the bush or pins multiply with the number of pins. First you calculate the bearing load and then multiply with N. So that is PB into D2 into L into N. Bearing pressure multiply with the area and multiply with the number of pins. Next, the torque transmitted by the coupling. How much torque transmitting? Calculate the torque transmitted. So load and the radius W into N into D1 by 2. So here N is number of pins. So what is this load? This load is bearing load. The bearing load already you have calculated, determined in previous step. So that is PB into D2 into L into N into D1 by 2. Direct shear stress due to the pure torsion in the coupling. Direct shear stress induced due to the torsion. So how to calculate? Shear load upon area. 5 by 4 into d1 square, w by 5 by 4 into d1 square. Since the pin and the rubber or leather bush is not rigidly held in the left hand place, therefore, what will happen? The tangential load at the enlarged portion will be exert a bending action on the pin as shown in figure. In this shown, the bearing load acting on pin. The bush portion of the pin acts as a cantilever beam of length L. The bush portion up to here, it acts as a cantilever beam. One end is fixed, other end is free. But here type of load is uniform, UDL, uniform distribution load, not point load. So that's why the bush portion of the pin assumed as a cantilever beam. So also assumed the uniform distribution of the load along the bush. So find out a maximum bending moment of the pin. So calculate the bending moment of the pin. W into W multiply with L by distance, L by 2 plus 5 mm. So we know that the bending stress equation is equal to sigma is equal to m by z. So here you can calculate W into already bending moment calculated divided by z. You can take z is moment of polar moment of inertia 5 by 32 into d1 to the power of 3 cube. Since the pin is subjected to the bending and shear stress, therefore the design must be checked for. Here also you have to check for maximum principal stress or maximum shear stress by using following relation. You know maximum according to the maximum principal stress theory. So what is the equation? Empirical relation. Half into sigma plus the square root of sigma square plus 4 tau square. Similarly, the maximum shear stress on the pin half into square root of sigma square plus 4 tau square. You must check for shear stress or the principal stress. Check this stress with the given allowable shear stress or allowable normal stress. This value always should be less than the allowable shear stress or allowable principal stress. Shear stress or principal stress. Then only your about design is safe. Whatever you calculated, the diameter of the pin or a number of pins, bending moment and diameter of the shaft, all dimensions are in safe condition. Clear? So like this, how to design of a bushed pin type of the coupling. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.